Alright, so if we look here, I got kicked off, so that's a bummer, but that's okay. So if we wanted to see our uncertainty in moles, we know our molarity of our zinc sulfate was 0.05002 moles per liter. That's concentration. And when you work that out, I believe you get 1.701 times 10 to the negative fifth moles. Alright, if we wanted to, we're trying to figure out our uncertainty in our moles. So using our uncertainty and using the moles of zinc sulfate that we were given, this is the number we get. Well, now let's compare that. Let's take those moles divided by our number 15, which was our average moles, which I believe that was 9.75 times 10 to the negative 4 moles. In this example, it would have been this answer right here. That's where I'm getting this. And you get 0.017, which is 1.7%. If we wanted to see the uncertainty in our volumes, what does that 1.7% mean? Well, let's compare it to our volume. Let's take our uncertainty and our average volume for zinc sulfate, and these are all made up numbers because I can't use the same numbers that you guys are getting from the lab. So if you're wondering where I got these numbers from, they're the numbers that I put in those 3 titration burette problems. If you do it this way, times 100, it also comes out to 1.7%. So what does that mean? That means this 0.34 milliliters is only 1.7% of this 19.49 milliliters, which is not bad at all. So we're going to use that 1.7% to find the uncertainty in our ratio, but that's technically the answer. You can do it with your moles or you can do it with your volumes. For this ratio right here, you want to take your moles of zinc sulfate, which is your number 15, that's moles, and you want to divide it by your number 10 moles. You might get crazy numbers, like, I don't know, you might get 9.83 times 10 to the negative 4th, and you might get 6.28 times 10 to the negative 4th. Made up numbers. How in the world are you supposed to get nice ratios for those? Well, just take the top number and divide by the bottom number, and look at that. It comes out to an easy 1.56 over 1, which makes a lot more sense, because now you know the ratio. When you go back and compare it to the front of your lab, you know that you're going to need 3 moles of zinc sulfate for every 2 moles of potassium ferrocyanide. So hopefully this is making a little bit more sense for you. The back, you're just calculating the uncertainty in the ratio, just what we just got done doing. That's all you're doing. It's going to be the same, because the uncertainty in the ratio is the same as the uncertainty in the volume of zinc sulfate, and it's the same as the uncertainty in the number of moles of zinc sulfate. And the example that we just had was 1.7%. Well, what in the world does that 1.7% mean? Well, take that uncertainty. This is the one that we have. This isn't your number. This is my number from the data that I gave you. You'll have your own number. And multiply it by your number 15. And then I believe my number 15 was at 9.75 times 10 to the negative 4th moles. It's a little bit confusing with using the different numbers because I'm trying not to give you the answers, but that's what you would do. So for yours, you would just take your uncertainty. I shouldn't say uncertainty, I'd say your percent uncertainty, so you don't mess it up. So that percent that we just calculated, you won't have 0.017. You will have a different, something close, but not that. And you will put whatever your number 15 is. And that will give you your number of moles. And that's your uncertainty. Okay? And that's just saying that your mole ratio is going to be plus or minus that number of moles, which is fine. For this guy right here, you have to pick reactions 1 through 4, and if you don't know where those reactions are, they are on, I don't have that one pulled up, they're on the original lab experiment write-up. You were given 4 equations, and then just make sure you write sentences here explaining why. Explaining why you picked the ones you did. Okay? So hopefully that helped you a little bit. The challenge, I almost forgot about the challenge. Now usually they have you guys doing this and you just put some solutions in there, like this one you would just put DPA in a test tube and see if it was blue. This one you would put DPA and zinc sulfate in a test tube and see if it's blue. And this one would be mixing all 3 in the test tube and seeing if it's blue. Well, how are you going to do this? You have to go back in the video and you have to look to see what color the flask was when you were beginning the titration. When she added the DPA. When she added the DPA to that flask, was it blue? That, if it was blue, that means the DPA must have caused it to turn blue. Okay? Then when she's titrating, she has DPA and zinc sulfate in that flask. While she's titrating, while she's adding the solution from the burette, she has these guys in the flask. Well, is it blue? If it is, then this is it. Or is it C, after she adds the perfect amount of DPA, zinc sulfate, and potassium ferrocyanide? Is that when it's blue? One of these is right. And then just do a short explanation, sorry, of what your proposed mechanism is. So you have to explain the color that you saw when this was happening. And then make your prediction here. Make your predictions here. Okay? All right. It's very easy. Don't make that challenge hard. It's common sense easy. You're just looking to see when it turned blue. All right. Now, all right, so now we are going to learn how to find standard deviation on our calculators. I'm using those bogus volumes from the titrations that I've been using this whole time. So let's go to Stat. You have a Stat button right there. And if you don't have a graphing calculator, you can use Desmos or you can find one online. Enter. Now I have volumes in, I have some things in here. I don't know if it's going to let me do this. I don't want to erase these yet. So if I wanted to use these, you're going to enter your values in L1. Like you can do 19.5, 9, 18.86, and 20.02. All right, say that you have all your values in there. And if you do Stat again, I keep on pressing second. And then if you go to Calculate, one variable stats, press Enter again. Right here. I think this is so much easier. Plug 3 numbers in your calculator, press Stat, and enter a couple times. Right here, this SX, obviously this isn't your answer, so don't write this down. This SX is your standard deviation. And to get standard deviation of the mean, just take this number and divide by the square root of 3. So you could either do it on Excel or you could do it on this calculator. I think it's easier to do on the calculator. Okay? Different ways to find your standard deviation. All right. I hope these helped. If you have any more questions, let me know.